Alright, here we got lesson 5.3, which has got some new factoring in it. We're going to continue to work on finding zeros, but in order to find zeros of these larger polynomial functions, we need to be able to factor them. So we're going to work our ways towards some new techniques that you haven't worked with before, but we're also going to look at old school factoring. Only what I mean by old school is what we've already done in chapter 4. You know, when I had something like x squared minus 5x plus 6. What times what is 6? Adds up to -5. That type of thing. We can do that type of thing as long as the degree is even. The second term has an exponent which is half of the degree. And then there's a constant term at the end. And a constant term is one that doesn't have an x by it. So we could have an even degree, like the degree could be 8, so it could be x to the 8th. The second term could be half that, something x to the 4th, and then you've got a constant term, just a number 1. Okay, so that's the type of thing we need to look for when we're looking for old school factoring with a twist, as I call it. So example 1. Take out what they have in common first. They all have a 4x squared. Divide them all by 4x squared. And oh look, it's just like the one I had up there. I said I've got x squared minus 5x plus 6. So up here I said, what if I had x squared minus 5x plus 6? You turn it into x minus 2, x minus 3. It's -2 times -3 is 6, and -2 plus -3 is -5. We do the exact same thing down here, but you can't have x and x. In order to get x to the 4th in front, you're going to need x squared and x squared. And the order that you have here, -3, -2, that doesn't matter. If you had them flipped around, x squared minus 2, x squared minus 3 second, that'd be just fine. We're going to continue to look to factor. I've got x squared minus 3. Technically, I wouldn't say you could factor that. If you look at the book, they'll have you factor that because they'll say, oh, treat it like a square minus square. They'll have you factored into x plus 3 and x plus root 3, excuse me, and x minus root 3. But at this point, I'd say, that's not factorable. I don't want square roots in my factors. So at this point, we're going to figure out what makes these all equal 0. So there's 3 terms here. There's 4x squared, I need that to be 0. There's x squared minus 3, that's 0. So there's 3 factors. Those are my first 2. My third factor is x squared minus 2 equals 0. You know, when I say factors, like if I say factor 12, you turn that into 2 times 2 times 3. 2 times 2 is 4, 4 times 3 is 12. Those are the factors of 12. These are the factors of my polynomial here. 4x squared times x squared minus 3 times x squared minus 2. So that's why I call them factors. What makes them equal 0? Well, this one would just be x is 0. This one over here, add 3, get x squared equals 3, square root, you get x equals plus or minus square root 3. Don't be that guy, make sure you get the plus or minus. Same thing over here, you get x squared equals 2, so x is plus or minus root 2. Those are your zeros. There are 5 of them. There could have been up to 6 because it was 4x to the 6th. And there really is 6. It's just that you've got 2 zeros. So there's really 6 of them, but there's 2 zeros. Okay, so there's 5 different ones, but there's really 6 zeros. 2 of them are where x equals 0. Kind of a review from our previous section. If I wanted to graph y equals 4x to the 6th minus 20x to the 4th, plus 24x squared, I now know that it has zeros at 0, positive square root 3, which is a little over 1.7, negative square root 3, negative 1.7 something, positive square root 2, which is 1.4 something, and negative 1.4 something for negative square root 2. The lead term is 4x to the 6th. The degree is 6, so it's like a parabola that opens up. I was going to go through, I don't know how low this goes. I use my calculator to read relative mins and maxes, but it comes back up like this. It's going to go up to a certain level. Oh, if I plug in 1 or -1, I'm going to get the same thing. Looks like if I plug in 1, I'd get actually 8. So it goes up about to here. Now what happens here? It approaches 0 from both sides. Because 0 has a multiplicity of 2, there's that bounce. So that's a review of what we did before. It's got 4x squared, there's a 2 there. That means it's got a multiplicity of 2. So it bounces off the x-axis right here. Otherwise it goes through because the rest of them have odd multiplicity. So it's a quick review of the graphing that we did and talking about the end behavior from before. Okay, example 2. I got x to the 4th, that's even. I got x squared, that's half that. So I go ahead and say 1 times 1 is -21. Adds up to 4. That'd be +7 and -3. So I need x squared plus 7 equals 0. I need x squared minus 3 to equal 0. This one I subtract 7 and square root. So it's plus or minus square root -7. Well, that'd be plus or minus I root 7. This one, we already did x squared equals 3 on the one above. That'd be x equals plus or minus root 3. You have 4 zeros. How many real zeros do you have? 2. These are the real zeros right here. How many imaginaries? 2. Here, those are right there. But there are 4 zeros, it's just that 2 of them are imaginary. Okay, now we've got a new pattern here. We used to do, we had binomials, and there's only one binomial we've been able to factor so far, and that's when it's x squared minus b squared. Like if I had x squared minus 100, we turn that into x plus 10 and x minus 10. Now you square root them both, have 1 plus 1 minus. That's the only binomial we've been able to factor so far is x squared minus b squared. Well, now we got a couple more. You can actually do a or x cubed plus y cubed, or a cubed plus b cubed. Or you can also do subtract. So when it's a cube and a cube, it doesn't matter if it's plus or minus, you can do either one. In order to do these cubes, you kind of want to know some of the cubes. So perfect cubes are 1, 8, 27, 64, 125, 216. Any of them are fair game, but these are the ones you normally see. Well, you might want to see 10 cubed is 1,000. So those are the ones you're going to be on the lookout for. Look out for those numbers. So in example 3, I have that number, I have 8. But I can't use 8 because it's not 8 cubed. I need to write this as something cubed plus something cubed. So it's x cubed plus, that's not 8 cubed. So what you do is rewrite 8 as what it is in cube form. So this is x cubed plus 2 cubed. Then you write down the factors. Factors are a plus b. Well, in this one, a would just be x and b would be 2. So it's just x plus 2. There's no powers there whatsoever to begin with, just x plus 2. And then the patterns like our square dance that we've done for the binomial squared. You know, where we got a binomial squared, we do first one squared, twice the product, last one squared. Well, this one's first one squared, opposite of the product. So you still multiply these and get 2x, but then you subtract them in this case, and the last one squared. That's the factorization. I did say I wanted it to equal 0, so we have to find the zeros. This is a little tricky here. The first one's easy. The -2 is a real 0. -2 plus 2 is 0. But what makes this equal 0? Well, that's a quadratic expression. So you're either going to complete the square or use the quadratic formula. I would just say, hey, let's use the quadratic, be consistent with that. So if I use the quadratic for this right here, it'd be x equals -8, so that'd be 2 plus or minus square root. -2 squared minus 4 times 1 times 4. All over 2 times 1, because again, A is 1 and C is 4. So this is my A, this is my B, this is my C. So I just need to evaluate this. This would be 2 plus or minus. The discriminant, I don't know why I have 2 to the 4th right there. This is 2 squared, thinking ahead apparently. So we got b squared minus 4ac. So I'd have 4 minus 16, this would be negative 12, all over 2. Don't cancel these 2's up front, that's illegal because of the plus or minus. Simplify, square root negative 12, you'd have 2 plus or minus 2I root 3 all over 2. 12 is square root 4 square root 3, so that's 2 root 3. And then there's I, which is negative. And now you can take and divide out 2 out of all of them. So we're going to take this right here, divide 2 out of all the terms, and it'd be 1 plus or minus I root 3. So divide by 2, you get 1, divide by 2, you get 1, divide by 2, you get 1. The first term doesn't cancel, it turns into a 1. Those are your 3 answers. Example 4. I got a binomial. What am I going to do? I'm going to check to see if it's either square minus square or sum or difference of cubes. Well, this is a cube minus a cube. Now it's not 64 cubed. I need to write 64 as it is on the left-hand side up top here where I wrote down my numbers. 64 is 4 cubed. So I'm going to write 64x cubed as 4x quantity cubed. And I can't leave it as 27. That's not 27. I'm going to turn that into 3 cubed. So I write down what's up here without the powers. Then I do first one squared. 4x times 4x is 16x squared. Opposite of the product. 4x times negative 3 is negative 12x. Switch that, plus 12x. And last one squared is plus 9. Same type of deal to make it equal 0. This one would be 3/4 because you add 3 divided by 4. That's what makes 4x minus 3 equals 0. Add 3 divided by 4. And this one over here, you'd have to do the quadratic. It would be negative 12 plus or minus the square root. 12 squared minus 4 times 16 times 9, all over 2 times 16. So when we do the discriminant on that one, memory serves me correct. It's negative 432. I'm going to double check. And yes, it is, negative 432. So this would be negative 12 plus or minus the square root of negative 432 over 32. Got to simplify the negative 432. Well, I know that 144 goes in there 3 times. If I was going to break down the square root of 432, it would be 144 times root 3. So that's 12 root 3. So this turns into negative 12 plus or minus 12I root 3. I didn't have the negative up here, so you got an I. All over 32. And then what goes into all these? 4. Divide them all by 4. Negative 12 over 4 is negative 3. So we got plus or minus 3I root 3. And then I got to divide the 32 by 4 and I get 8. There's my 3 answers. 1 real, 2 imaginary. That's what you get when you do these cube minus cubes and their equations, or cube plus cubes. You get 1 real and 2 imaginary. Okay, one more. Well, these aren't cubes here, but if you follow the first step, which is to take a 2 out, you've got cubes. Again, 8 is not cubed. You have to rewrite it as what cubed 8 is. So what cubed is 8? 2 cubed. And then 1 cubed. This 2 out front really doesn't end up doing anything, but if I was going to factor, I'd have to have that 2 in my answer. So I'm just factoring this. It would be 2x plus 1. Just write what's there without the cubes. First one squared, 4x squared. Opposite of the product, negative 2x, plus last one squared. Answer for this would be negative 1/2, negative 1 divided by 2. And then over here, you got to go through the quadratic formula. You got 2 plus or minus square root, negative 2 squared minus 4 times 1, all over 2 times 4. 2 plus or minus the discriminant would be negative 12 again, all over 8. plus or minus 2I root 3. All right, divide them all by 2, and you get 1 plus or minus I root 3 all over 4. If you divide them all by 2, that's 1, that's 1, that's 4. All right, well, I was going to finish up all the notes in one video, but my heater is not cooperating, and I know that muffles my voice, so I'm going to hold off on the grouping for another video, and I'll also do the example 6 on that other video as well. So thanks for watching factoring cubes, sum difference of cubes, and then those ones that trinomials that add x to the 4th, x to the 6th, x to the 8th. We're just doing the old school factoring. Have a great day.